and completing its one rotation, while which the curve is traced, is called cycloid. In many of the MCQs, it has been asked that what is the curve traced by a super gear? Super gear is a circular gear. If it is completing its revolution, then obtained curve would be cycloid. And what is the curve traced by a bevel gear? Bevel gear is on some degrees, so those curve traced called epicycloid or hypocycloid. Now we will see that how we can draw cycloid for a circle of 60 mm diameter. Please look at it very carefully. It may be very tedious. It is a very lengthy procedure to have a cycloid drawn, but look very carefully so that you will have a brief idea how you can draw a cycloid. First of all, draw a 60 mm diameter circle. First of all, 60 mm diameter. Or drawn a 60 mm diameter circle. Now we'll see that how we can utilize this 60 mm diameter circle, and we need to take this 60 mm circle if it is revolving for one revolution. So first of all we will need to take the center line for the same. Take the center line first of all. Now what would be the periphery of a circle? Periphery of the circle is called, if you see, periphery of circle pi into d, where pi is equal to 3.14, d is equal to 60, which means that the answer is 188.4 mm. It is the periphery of the any circle. Now we will see that where it can be utilized. First of all, we need to take this circle revolved for a one revolution. We need to divide this circle into 12 equal parts. So 360 divided by 12 is equal to 30 degrees. We will divide this circle into 12 equal parts. Draw very light lines, or else you will feel that you are traced between number of lines. Draw very light lines, and always make an habit to draw very smooth curves as well. Now we have got this 12 equal parts. Now here comes the periphery. Periphery length is given as 188.4. So from the bottommost point we will take a perpendicular line of 188.4, which would be a complete one revolution. If a circle is revolving for one revolution, then it will travel this much distance. It will travel this much distance. Now from that point itself, draw a line at 60 mm so that it can be perfectly perpendicular to this line. Now draw lines touching to this portion, very light one. From each part draw the line. So when you are just passing through parts, you will feel that two parts would be intersecting with each other. Likewise, I have taken all the projections towards this line. Now when this circle will complete that full revolution, it will reach over here, and we have taken all its projections. Now let's name the circle as 1, 2, 3 till 12. Now for each part, center will shift, so we need to divide this 188.4 line into 12 equal parts. It is not very much okay to divide this sort of line, so we will use this system to divide a line. Draw a line of 12 centimeters or 120 mm at any angle. Divide that line with equal parts. As we need to divide this line into 12 equal parts, I am dividing this line into portion of 10 mm each. Join open end with this. Take parallel lines. Take parallel lines to this portions each other. Make sure that all lines are parallel and your equal divisions will be achieved very properly. All parallel lines I have taken. Now take perpendicular line from this, just mark the point. This is the center shifting by part. It is the representation of this only. If we considered this portion as C0, then it would be C1, C2, C3, C4, so on till C12. I'm again saying that this is a very tedious process. Please look at it very carefully, or else you cannot understand how you can trace the cycloid. Now we need to trace this cycloid for a diameter of 60 mm. So I am taking this radius. When I am taking the center C1, I am marking an arc on line 1, taking again radius as same, radius as diameter as C2, marking an arc on second line, taking center as C3, again radius same 30 mm, marking a line on third line, C4 same arc on fourth line, C5 arc on 5-7 line, C6. When you come to C6, the arc would be completely tangent, as it would be a radius itself. C7 will be going down again, C8, again C9, go down once more, C10 would be 210 line, C11 would be this portion. So we have got various arc, taking C1 to C12 as center, radius as 30 mm, plotted arc according to the center, C1, then arc on the 1 line, C2, then arc on the 2 line, C3, then arc on the 3 line, C4, arc on the 4 line, and so on till the 12. We have got the various arcs. By joining it, we can get our desired cycloid. We can either join by French curve or by manually. Join one by one. Join the bottom periphery line also. So this is how you can trace your cycloid. Don't forget to name the points which you have taken. P1 to P12 it would be have. Don't forget to name the curve as well. It is called cycloid. Even give the dimension of this pi into d. Right, like this, pi into d is equal to 188.4 mm. So this is how you can trace your cycloid. Let's see a quick look at the how we can draw the cycloid. Cycloid means that any curve following its one revolution and the curve traced. First of all, we will draw a circle of diameter 60. Divide it into 12 equal parts. After dividing into 12 equal parts, from the bottom point, we will draw a periphery line. What would be the periphery? Pi into d, which means that over here it would come around 188.4 mm. We have drawn 188.4 mm line. Now we have divided this circle into 12 equal parts, which means that each part will be rotating one by one. So we have given the name 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Dividing this pi into d line into 12 equal parts, we will get our 12 centers, C1 to C12. We have got the 12 centers, we have got the radius of the circle. Now we need to take out the arc. Our circle diameter is 60 mm, which means that we need to take the radius of 30, taking C1 as center, putting an arc on the one line, and so on. C2, arc on 2 line. When you come to C6, the arc would be properly tangent. Then again go downward till C12. Join this arc with a smooth curve, either using French curve or manually. Name the point, give the name to the curve, give the proper dimension, and this is how you can draw a cycloid. That is the end of the part 2 of GTU exam paper July 2009 engineering drawing. This is Arpan Pandit. See you soon.